So this is another next properties about first shifting properties. So the first shifting properties, so what is that means actually? So let's say you have the function like this one. Let's say your ft is no longer like the simple function like that one. So you have something like multiplication function t with the exponent function. So exponent a t something. So the gt maybe it can be sine, you can be cos, you can be t functions. So whatever is here. So as long as this is the t functions. So the Laplace transform for this one is very easy. So you just Laplace transform this to this. So you will get something like gs minus 2. You're going to shift from gt to gs Laplace transform, and then once you get the gs, then you shift to s minus a. So it depends on the values here. So what is that actually? So you can just try to take a look on this one. So this is the process flow. Starting, you try to identify, let's say this one, you try to identify. So what is your gt here? So once you get the gt, and you just Laplace transform to get the gs first. So once you get the gs, and then you proceed for the gs minus a. So a is based on which one? So here or which one? So obviously I know that this is the a, and then this is the shifting because this is the exponent function, and then this is the gt functions. So this is my gt here. So this is my a, obviously, and then next, so this is my gt's. So once I have this one, so I can just write the form like this one. So what I do next, so once I get the gt, so this is the first starting flow, and then I just Laplace transform to get the gs. So once I get the gs, and then continue to shift the answer from s to s minus 2. So what is that mean from s to s minus 2? So this is meaning that every s over this one, you shift to s minus 2. So the same thing goes for this one, you get for s minus 2. So once you have this one, so what you did here is this one, you're going to substitute to this, you will get a final answer for the Laplace transform. So the same thing, I show you the next example. This is the same way, and you have the start and the end. So let's say the step 1, try to identify. So what is the a, what is the gt here? So obviously I know that, so this is my gt. So what I did here, I just Laplace transform for this one. So for sine, it's very easy, I just refer to the table. So this is a Laplace transform. So when I get this one, so what I did here is I'm going to identify my a here. So my a, this one, so this is my a, so a is 2, so this means this is the s minus 2, so it's a 4 over s minus 2 square plus 16. So this is another example case here. So this is another example. So my ft, so first of all, I'm going to identify, so what is my gt here? So this is very simple. So this is my gt, and then this one is my a. A is a negative 2. So just Laplace transform for the gt. So this is what I get here. So again, so this is somehow like we're using the linearity. We just Laplace transform the t power 3. So this is what I have here. So once I have this, I just simplify, or I can just make it this one, the solution form, and there we get this one. Because this is the gs, and this is the s minus a, right? So my a is 2, negative 2, so this means the minus 2 plus 2. So for every s here, they become s plus 2, and this one s here, they become s plus 2. So this is my answer for this.